Dr. E's not going to talk about it. If I carve it down, and you're probably not going to do it that way.
You don't remind me what chapter 4 or 6? Which one was it? 6? 6.4? 6.5? No, thanks. Appreciate it. That's all right.
I think it's 6.5. That's all.
We'll just do a 4x4 matrix. That's all. I don't know if they did that one, but we can do that one. No, that's the determinant. I'm not ready for that yet. That's Kramer's rule. That's easy stuff. So that's not it. Must be the previous section. 6.4. Maybe we can do a couple to get y'all discouraged. Maybe get you to quit. That's not it either. All I need is 3x3. They're just multiplying. I don't care anything about that. Alright, so it must be 6.3 we're on. Yep. That was too easy. Well, they don't challenge y'all very much, do they? Okay, there we go. Did we do one of these? Check your notes. So I think we did 2 last time. Not the free day, but 2 before that. I meant the class before that. Make sure we didn't do this one. I have to go get a stylus because I did the last class without a stylus because teacher stealing styluses. Did we do one like that? I don't think we did one with that big of numbers, did we? Go ahead and start it. Elementary row operations while I go downstairs and get a stylus. Shouldn't take you more than 30 minutes. Y'all done yet? Or y'all quit yet? Y'all not gonna talk to me, okay? That's fine.
My brain is fully immersed in that.
Yeah, I'm sure. I'm sure. All right. There's our system of equations. We're going to change it into a matrix, do elementary row operations. Then get the answer. 1, 1, negative 3, negative 33, 2, negative 1, 6, 69, 1, negative 2, 5, and 34. We could rearrange and make some things easy. I don't know if it'll help us or not. Take this one, put it up top. 1, negative 2, 5, 34. Put this one in the middle. 1, 1, negative 3, negative 33. And put this one last. 2, negative 1, 6, and 69. Now, why did I do that? Mainly because I have 2 1s right here, and that'll keep us from having to do a couple of steps. It may not, I don't know. Just kind of something to start off with. I can get rid of this 1 by multiplying row 1 times negative 1, add it to row 2 to get new row 2. So, row 1 multiplied by negative 1 give me a negative 1, a 2, a negative 5, and a negative 34. Going to add it to row 2. That'll give me a 1, 1, negative 3, negative 33. And that'll give me a 0, a 3, negative 5, negative 8, and a negative 67. So 1, negative 2, 5, 34, 0, 3, negative 8, negative 67, 2, negative 1, 6, and 69. Now what? Need to get what? 0 right there. So let's take this to the next page. I'm going to take row 1, multiply by negative 2, add it to row 2, row 3, get new row 3. Row 1 times negative 2 give me a negative 2, a positive 4, a negative 10, and a negative 68. 2, -1, 6, and 69. Give me a 0. 4 minus 1 is 3. -10 minus 6 is -4. -68 plus 69 is 1. So that'll give me a 1. -2, 5, 34. 0, 3, -8, -67. 0, 3, -4, and 1. I'm going to get a 1 here, so I'm going to divide by what? Divide row 2 by what? Or multiply by 1/3. And that'll give me a 1, -2, 5, 34, 0, 1, -8/3, and -67/3. And then 0, 3, -4, and 1. Now we need to copy that. Put that to the next page. What was that top number, please? -2. Now I need to get a 0 here, so I'm going to take row 2, multiply by -3, add it to row 3, and that'll give me new row 3. -3 times row 2 be 0, -3, -8, or positive 8, and 67. We're going to add that to row 3, be 0, 3, -4, and 1, be 0, 0, 4, and 68. And it's going to be 1, -2, 5, 34, 0, 1, -8/3, -67/3, and 0, 0, 4, and 68. Now I need to make a 1 here, so I divide row 3 by what? Divide by 4, and that's going to give me 0, 0, 1, and 4 going here. What, 17 times? Help me out.
Yep.
So I'm going to take a red marker, change that to 1, and change that to, what I said, 17? Now I've got 1, -2, 5, 34, 0, 1, -8/3, -67/3, and 0, 0, 1, and 17. Take that. Now you can do whatever you want to, but you gotta get rid of these 3 numbers right here. So I'm just gonna work from left to right. I'm just gonna get rid of that -2. So I'm gonna multiply row 2 by 2, add it to row 1, and that's gonna give me new row 1. So row 2 be 0, 2, 16/3, and I forgot what I was doing. Okay, 2 be -134/3. And I'll check my math there. and then add it to row 1, which would be 1, -2, 15 thirds, and 3 times 34 is what? 102. So that'd be 1, 0, 1/3, and I have no idea, 32 thirds. And that's going to give me 1, 0, -1/3, -32 thirds, 0, 1, -8 thirds, -67 thirds, and 0, 0, 1, 17. And I'm going to multiply this by -3. And when I do that, no, because you do 1. You don't want to do 1, 0. So I'm going to multiply row 3 by 1/3, add it to row 1 to get new row 1. And row 3, that's an easy one. 0, 0, 1/3, 17 thirds. 0, 0, 1/3, and 17 thirds. And I'm going to add it to row 1, which is 1, 0, -1/3, and -32 thirds. I think that's 32, isn't it? Yeah. And that's going to give you 1, 0, 0, 17 minus 32, -15 thirds, which is negative what? 5? So new row 1 is 1, 0, 0, -5, 0, 1, -8 thirds, -67 thirds, and 0, 0, 1, 17. And now I need to get a 0 there, so row 3, multiply by 8 thirds, add it to row 2 to get new row 2, and it'll be 0, 0, 8 thirds, and 17 times 8 is 126, 136. And then that's going to be added to row 2, that's 0, 1, -8 thirds, and -67 thirds, and that's going to give you 0, 1, 0, 53, what is it? What? 69 thirds, which is 23. So our final answer is 1, 0, 0, -5, 0, 1, 0, 23, and 0, 0, 1, 17. Therefore, these 3 lines intersect at -5, 23, and 17. So we're talking about a 3-dimensional graph. Talking about, and this is going to be, usually the way this is y, x, and z. So -5, -5 is 1, 2, 3, 4, 5, and then 23 in the y direction, be up here, and here, and then next off of it, and then 17 will be this direction, and then 17 down here, and straight up. you're talking right there. That's your basic. These are all property. So the intersection of these three lines is right here. That's the intersection. The reason you got a box there is so you can draw it with the initial graph and you can actually see the that's your intersection point. Yeah. Anyway, all right, now let's take the same problem and do it by Kramer's rule. And how do you do Kramer's rule? Well, Kramer's rule really is easier than elementary row operations. Elementary row operations you have to learn kind of like you have to do with factoring using the reverse FOIL or shortcuts, or you have to use the P word. What is it? What do you have to do with musical instrument to get good at it?
Practice.
Practice, that's it. You have to practice. No excuses except you suck at it because you don't practice it. So if you really suck at the elementary row operations, it's because you haven't done enough problems. Period. Kramer's rule, it's kind of like complete the square. I taught y'all how to complete the square. And the reason people don't teach you how to complete the square is they don't want to take the time to explain to you how to do it. And then y'all, I mean the students, don't want to what? Practice it. So what do they fall back on so they won't have to teach it and you won't have to worry about it? The quadratic formula. And then you use the quadratic formula and they beat you over the head with it and then you don't use it in calculus. So what do they do with this? Well, they tell you that you need to learn how to do elementary row operations because it helps you in programming and it helps you with the elimination method. So they don't want you to practice it because it takes too long for you to learn it, and they don't like to teach it because it takes too long for them to teach it. So what do they fall back on? Kramer's rule is the quadratic formula of solving systems of equations as far as matrices. So you still have the matrix of 1, 1, negative 3, negative 33, 2, negative 1, 6, and 69, 1, negative 2, 5, and 34. And we're just going to concentrate on this. There's three variations of this. There's three, actually 4 different matrices we can get from this. But before I do anything, I'm going to change these guys if I can. Probably not going to let me, but no, it's not. So I'm going to erase these. 33, 69, and 34. 33. 69. Are those correct? Make sure the signs are correct. I'm going to change those to red. Alright, now the first determinant I want you to come up with is just these 3 by 3 right here. This is 3 by 3. And we're going to call this the coefficient matrix. is a Huberdism, so you're not gonna see it in the book. In other words, the coefficients of all your variables, we're gonna call it the coefficient matrix. 1, 1, negative 3, 2, negative 1, 6, 1, negative 2, and 5. Okay? We're going to take that guy and we're going to pull it over here to the right. We're going to pull it right there. We're just going to, and we're going to put it right out to the side of coefficient matrix. We're going to put DEN. DEN. Like the room in your house where the TV is. DEN. Next, we're going to set up another matrix. In this matrix, we're going to call it the X matrix. And we're going to put 1, negative 1, negative 2, negative 3, 6, and 5. And instead of putting the X column, I'm going to put the red column. Negative 33, 69, and 34. And that's what we call the X matrix. I'll make it a little bit smaller. Now the X matrix, I'm going to put right beside it, just like I did the denominator over here. I'm going to put X mu. Then we're going to do the Y matrix. And right beside the Y matrix, I'm going to put Y mu. And that's going to be 1, 2, 1, negative 3, 6, 5. And then in the Y column, I'm going to put my red numbers, negative 33, 69, and 34. And then what do you think the last one's going to be? Z matrix. And that is your Z numerator. 1, 2, 1, 1, negative 1, negative 2. And then negative 33, 69, and 34. And now you set up pretty much the setup of the problem. And so all you need to do is get those 4 matrices. Now I just got to find the determinant. Now the determinant is basically a operation you use with matrices to find out a number that it generates. That's the definition. It's not a number that's important for any other thing except for parameter. So, how do you find the determinant? Well, with a 3 by 3, it's a little bit, let me just go ahead and show you how to find the determinant. And this next page, you can skip a page in your book. I think it's NANT, I don't know. But anyway, determinant. If you have four numbers like 2, 3, 4, and 7, 2x plus 3x and 2x plus 3y and 4x plus 7y. You can find the determinant with just these four numbers, roll a fish, and his mouth. And that is 2 times 7 minus is his mouth, 4 times 3. And 2 times 7 is 14 minus 12 is 2. So 2 is the determinant of this 2 by 2 matrix. And that's how you find the determinant. Now what about 3 by 3? We're getting there. 3 by 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. The first thing you do is, I'm going to take this and do it in red. Keep, change, keep. Write that up there. And write it if you have to write the word out. Keep, change, keep. That means the sign of these three numbers. Now you can do it 5 or 6 different ways. I could do keep, change, keep, and I could do 1, -5, and 9. I could do keep, change, keep, 4, -5, and 6, and then I could do I could do it 9 different ways. I could do it. Why am I choosing these three? Well, for one, since we were 2 or 3 years old, or 5 or 6 years old, which way do we read? Left to right. And this is the first row, so I always use that. But you can use any combination, horizontal, vertical, diagonal. You can use 7, -5, and 3. But it's a pain in the rear if you do it any other way, because you have to do something right after you set up your determinant. Alright, I'm going to set up the determinant, and I'm going to change these. Well, keep, that's a +1. Change, I change that +2 to a what? -2. And I keep this 3 right here, and these 3 numbers come down here. And I write +1, and I put a 2 by 2 matrix. -2, and a 2 by 2 matrix. And then +3, and a 2 by 2 matrix. I'll get this done now. Okay? Now, I'm going to take my handy dandy highlighter. I'm going to highlight this 1 right here. I'm going to highlight the column and row it's in. What does that leave you with? 5, 6, 8, 9. And that's your 2 by 2 matrix. Oops. 5, 6, 8, 9. No, it's not going to let me. That's fine, but it's not going to let me do what I want to do, so I need to push it. Okay, now I'm going to go to the -2. What does that leave? 4, 6, 7, and 9. Now I'm going to do 3. What does that leave? 4, 5, 7, and that. Now you do the determinant with each one, multiply and combine. So, fish, mouth, fish, mouth, fish, mouth. What's 5 times 9? Minus 48? Huh?
Yeah, maybe 3.
What's 4 times 9? Minus 42? Negative 6? Y'all check me. What's 4 times 8? 32. Minus 35 is negative 3. Y'all checking my math? Yes, Hubert. No, Hubert. We don't care, Hubert.
We're trying, Hubert.
And negative, what's negative 3 plus 12? Something not right. Y'all need to check my math. Oh, we're not supposed to come out with a 0. Because that would be undetermined. Check my math. 5 times 9 minus 6. 45 minus what?
48.
Okay, that'd be negative 3.
You get
36 minus 35, 42, 14, that's 7.
Okay.
I can't do that right now.
Okay, do it.
36 minus 42
What is it?
is negative 6.
Okay.
32 minus 35.
Okay, something's wrong. Go back and look.
Well, we're doing the same problem.
Yeah. Unless I wrote something down
I
wrong.
think, yeah, go back to your other page. You have a 2, a negative 2 up there, and change that.
Yeah, you're supposed to change that to a negative 2.
Well, I understand it's supposed to change the sign, but it's a 1.
Oh, well, that would cause it. Yeah. Which one are we doing? This one?
Yeah.
Okay, thank you. That would do it. I don't know where I got it from, but anyway, let's change that. That'd be a 1 right here.
Well, no, you did a different one.
Oh, yeah, okay, yeah, I just made it up. Okay, I'm just making this up because I was showing y'all. Okay,
Oh,
anyway, finish it up. In other words, the determinant here is
0.
0.
There's no determinant.
Well, 0 is the determinant. I'm sorry, I thought we were doing the same problem. Okay, anyway, do you see how to do a 3 by 3? That's how you do it. So, with that, let's go back to the previous page right here. And let's find this determinant right here. Okay? So, let's go over here, and I'll copy it. And we will put it on this page. Keep, change, keep. So that's going to be a positive 1, a negative 1, and a negative what? 3. So 1, negative 1, negative 3. Negative 1, 6, negative 2, 5. Negative 1, 6, negative 2, 5. 2, 6, 1, 5. 2, negative 1, 1, negative 2. What's negative 1 times 5? Negative 5 minus negative 12 is negative 5 plus 12, which is 2 times 5, 10 minus 6. Two times negative 2. Negative 4 minus a negative 1 is negative 4 plus 1 is negative 3. Right?
Negative.
7 minus 4 plus what? 7 minus 4 is 3. 3 plus 9 is, 3 plus 9 is 12. So 12 is our what? Denominator. Write that down. 12 is our denominator. So in your original, if you have an answer, like an answer blank on a test or something, you would put 12, 12, 12, because that is your denominator. Unless we did something wrong. Now let's take our x. This one's going to be fun, huh? Got big numbers. Keep, change, keep. So that's going to be a negative 33, a negative 1, and a negative 3. So negative 33, negative 1, and negative 3. Negative 1, 6, negative 2, 5. 69, 6. 34, 5. 69, negative 1. And 34, negative 2. What's negative 1 times 5? Negative 5 minus a negative 12. Negative 5 minus a negative 12 would be negative 5 plus 12, which is 69 times 5. Well, hold on. 70 times 5 is what? 350 minus 5 is 345. Okay. So that's 345. Minus 6 times 30 is 180, plus 24 is 204.
Yes.
And 340 minus 200 is 140, right?
Yeah.
So it'll be 101, 141. I'm sorry, we need to use a calculator for that. Way we don't
141.
think, so we can not make change in cash register. All right, 69 times negative 2 is negative 140, be what, 138? 70, right? And that'd be 140, what's 168, right?
138.
Yeah, 138. 138,
Negative.
that'd be a negative. And then minus a negative is going to be plus 34. And negative 138 plus 34 is negative what? 104? What?
Just like, I went ahead and multiplied.
You alright? Alright, 7 times 30 is 210, plus 21 is dang old 231. I'll do this one for you. And then 300 times plus 12 is what?
Oh, wait, 312.
What's this 6 times 4? What's this, a tip? You ever run into an airhead like that?
It's now become one of my biggest fears ever since I started working at this restaurant.
You're more conscientious of it, so you start thinking more.
So I might run into you. And
Good.
you can-
Oh, if I run into one of y'all, yes, I will do it.
It's a good thing I'm a busboy.
Just like I sent somebody Lowe's, I sent them looking for 5100 Zinc wrench.
Wow.
All right. So negative 231 minus dang old 372 minus 372 plus 312. So you owe $372. You have $312. That means you still owe what? 60 bucks? Huh?
Yep.
So that'd be negative 60. What was our denominator?
12.
Negative 60 divided by 12. Was it negative 12 or 12?
12.
Okay. Somebody tell me what our original x was on the first problem.
Negative 5.
It's a mirror. All right, so let's go to the next one. Let's go to y. So we go to our handy dandy y matrix. And grab that one. And I'm going to let y'all do this one. Because I have confidence in y'all. Confidence that you will quit.
Can you go back to the problem?
No, you should already have it written down.
Oh, yeah.
Yeah, we wrote it down like an hour ago. Hold on a second. Got to get this pulled up. There we go. As soon as I get that pulled up.
Oh, I got it.
Got it? Yeah. We wrote it down, yeah. Okay, Miss Anderson's not here today. Barron was here. He came in earlier. Borf is here. Crane. No Crane. Crenshaw. DeVore.
Here.
Evans is not here. Fisher.
Here.
Hall. Keller's not here. Lou is here. Moore is here. Nix.
Here.
Pace was here today. Page is not here. Well, I can't help that. All right. She's all right. Biel is here. Pruitt's here. Sabe's here. Sloger's here. Stone.
Here.
Stone is here. Walton. Woods.
Here.
Stone is not here. And Walton is not here.
Stone's here.
Oh, thank you. All right. That's done. Are you here?
Yeah.
All right. Give y'all 15 minutes. How long it'll probably take y'all. working these problems, you need to give yourself a lot of room, okay? This is not the time to try to do everything in between two blue lines of your notebook paper. All right? Like some of y'all try to do. All right, 69, 6, 34, 5, 2, 6, 1, and 5, and 2, 69, 1, and 34. Make sure I didn't make a mistake. 1 plus 33 minus 3. All right, 70 times 5 is 350. 350 minus 5 is 345. And 6 times 30 is 180, so that'd be 204. And yes, y'all should be doing this in your head. Just let me know. And 345, we did this a while ago, did we not? What did it come out to be? 345, 340 minus 200 is 45, be 41. Yeah, 141. Okay, this one you might need a calculator for. 2 times 5 is 10, minus 6 is 4. Did you do that on a calculator?
I have to.
Okay, I figured. 2 times 34 is 68. 68, okay, be careful here. 68 minus 69.
Negative.
You sure? Is this a tip? Okay, I'll do this one for you. 1 times 141 is 141. I did that one for you. Check it with the calculator. Plus 30 times 4 is 120. 120 plus 12 is what? And I'll do this one for you. Negative 3 times negative 1. Oh, it's 3. I was just making sure y'all awake. And 141 be 173, 273, 276. Help me out. Somebody take 276 and divide it by 12. What do you get? Yes, mirror. I hope that was our number. Was that our number? Good. So that would be, what was our first one? Something over 12. Negative 60 over 12. And this one is 276 over 12. And our last one is going to be something over 12. So let's see what the last one's going to be. Is it longer than doing elementary row operations? Some people say yes, some people say no. Is it as tedious as doing elementary row operations? No. This is more structured. This is more step by step than elementary row operations. Even though elementary row operations, if you get your own system, is very step by step. I'll show you something. Not a lot of people know this. What? Hold on. Well, did we not do a problem with elementary row operations? Oh, well, anyway, you see why I do the row 1 times 5, add it to row 2, new row 2? That's not in your book. That's something that I came up with as a student and as a teacher, and I keep teaching. All right? So you come up with your own system, and you use it, and you stick with it. If it ain't broke, don't fix it.
Nobody did stuff to you.
No, I dropped in. I dropped the body like 2 days after I said I can't handle this. Oh yeah. All right, let's take our other one. Z. and that's gonna be 1, -1, and -33. And that's gonna be -1, 69, -2, 34. 2, 69, 1, 34. And 2, -1, 1, -2. And I do the fish with the mouth too. What's -1 times 34?
-34.
Okay, and you've got that 70 times 2, that's 140. But it's minus the -140, so it's positive 140. So -34 plus 140 is what? I'll write it out. -34
106.
plus 140. 106? 2 times 34 is 68. Oh gosh, here we go again. Get your calculators out. 68 minus 69.
Plus. Yeah, negative.
-32.
So, on that -2 times 69, you put 140 up there. And then you put
Because 69 times 2 is 140. You didn't know that? I didn't subtract 2. It should be 138, should it not?
Yeah,
And then that's going to be 104. Thank you. I forgot I rounded and I didn't take off the 2. 2 times -2 is -4. 4 plus 1 is -3. All right, I'm going to do the first 2 for y'all. There you go. And then -33 times 3 is, that looks like 204. Somebody take 204 and divide it by 12.
17.
It's a miracle. Somebody tell me what we got for the first one.
-5.
And
17.
is that what we got for the first problem? And that's how you do Kramer's rule. And we're not going to do another one today because that's already fried your brain, because we did the matrix, we did elementary rule operations, and then we did Kramer's rule. But from here on out, that's all we're going to be doing. So Wednesday, we're going to be doing nothing but Kramer's rule the whole class period. And then after that, we're going to be practicing on nothing but just mixing them all up. Because you're probably talking about 5 problems on the test. And there'll be 20 points apiece. Oh, well, 5 problems and then maybe 5 of the stupid, you can't get them wrong questions. Okay? So everybody will make a 50 at least on the test. Or something like that. All right, y'all get out of here. Have a good day.
How about a quick question?
No, I'm not answering.